Hello everyone, can you please confirm if I'm audible? Okay, thank you, Ashwin. Venkata, please turn off your microphone. Okay, can you please confirm again if I'm audible so that we can start? Anyone, please? Okay, okay, so let's start our live session 2 for this second week of this course named Digital Electronic Circuits. So I'll briefly introduce myself again. I'm Anand Singhal, a PhD student from IIT Jodhpur, and again I'll be covering the content of week 2 today. So these are the contents that I'll cover, which contains basic logic gates, universality of NAND gates and/or invert gates, logic, Boolean algebra, K maps, and everything. So I'll try to cover as much as I can from these topics today. And okay, so let's start with the questions that we have. So let's start with few basic questions that we have. So okay, this session will be more of an interactive session. So side by side, you also can solve the questions because these these topics are quite what to say, quite easier to solve and quite simple. So you can also solve side by side, and you can also chat your answer whatever you are getting after solving these types of questions. So this is the first question that I'll solve. So here it is given that f is given by uh, x plus y. Oh, sorry. It is given by x plus x bar plus z, and then x bar y plus z bar. So before starting this question, I'd like you to tell basic simple axioms that we study in digital electronics. So these are when x is multiplied by x bar, it is nothing but zero. So x bar can be denoted by like this and like this. So these are the two methodology that we can take to denote x bar. So I can denote any of them anywhere. So please be careful. So x dot x bar is 0, and another is x plus x bar is 1. So we can also see that how is it going on. So 0, and when we take a bar of it, so it will be 1. So 0 multiplied by anything will be always 0. Again, if I take x as 1 and take the bar of it, so it will be again 0. So x dot x bar will always be 0, and same applies with, and so if I do 0 plus 1 and 1 plus 0, it will always be 1, since 1 added to anything will always be 1. So okay. Some more properties are, if we multiply x by x, so it will again give us x. 0 multiplied by 0 will give us 0, and then 1 multiplied by 1 will always give us 1. Some more are x plus 1 will always give us 1. So as I told that 1 added by anything will always give 1. And if you see for 0, it will always give x, whatever the value of x is. So 1 plus 0 will be 1, and 0 plus 0 will be 0. So it is dependent upon this x. And there is one more property which is x multiplied by 0. 0 multiplied by anything is always 0. It is basically an AND operation. So is there any doubt in these all properties that I have written? If anyone have any doubt, you can ask straight away. These are the basic properties that I have written. Okay, so let's start with the question now. So this was the expression. So I'll try to write it here. So let's try to solve this first two brackets, which is x into x bar plus z. Then we'll multiply it with the third bracket. So it will be nothing but x into x bar plus x into z. So we have just studied that x multiplied by x bar is nothing but 0. Since if you multiply 0 by anything, it will be 0. So it will be nothing but 0, 0 plus xz. And 0, if we add on anything, it will always be the variable. Here we have written that x plus 0 is always x. So this will be xz. So now if we add the third term in this, so it will be xz, x bar y plus z bar. So now I am multiplying it inside out, so it will be x bar y z plus x z z bar. So you can see there is a x bar, and here there is a z bar. We have just studied that if we multiplied the complement of any variable, sorry, yeah, here, if you multiply the complement of any variable with that variable, it will always give 0. So if I try to write it, it will be 0 into yz plus x into 0. And if you multiply 0 by any variable, it will always give 0. Here we have checked it. So it will be nothing but 0 plus 0, which will ultimately give us 0. So the correct answer to this problem is um, 0. Is there any doubt in this problem? This is quite basic. And as I have said that this will be more interactive if you can also write your answers side by side after solving. Yeah, so Ashwini, you are correct, and Latha, you are also correct. So everyone, please try to write your answers also. I don't want like only few people are writing the answers and others are also. Yeah, others you are also correct. So, is there any doubt in this question? Okay, so we can proceed. So yeah, this is a bit longer question. You can try. You can start trying this question with yourself. So what we need to do in this question, we just need to match the rows with this column. So there can be multiple answers, but we'll try to match the most perfect answer or the most applicable answer we can. So let me try to solve the first one. So we'll try to solve the complex equation first. Whatever complex is looking in these equation, we'll try to solve them first. So let me try to solve uh, this bracket first because this is the longest equation in this. So I'll try to write here. It is x plus y and it is multiplied by x plus y bar. So if I try to open it, it will be nothing but uh, x plus x y bar plus x y plus y bar, right? So we have just studied that if we multiply a variable with that variable itself, it will give the same variable. So the first term will be nothing but x. And if I write it as similar y bar plus xy plus y bar. So we have just checked that if we multiply any variable with its complement, so it will be nothing but 0. So it is 0. So now I'll try to cover this. So I'm taking x common from the first two terms. So it will be 1 plus y bar plus xy. So 1 plus anything will always be 1. So x into 1. It will be x into 1 plus xy. So anything multiplied by 1 will be the variable itself. So now I'll try to cover x plus xy. So now I'll try to write here. Lost the cursor, yeah. So I'm taking x common again. So it will be 1 plus y. It will give nothing but 1 plus anything will be 1 and x into 1 is x. So, okay, 4. So b will be 4. This we have confirmed. Okay. I hope I'm audible, right? Can anyone confirm if I'm audible? Hello?
Yes, sir.
Yeah, yeah. So we have the answer B as 4. Okay, so everyone has written A as 2. So please try again. Ashwani, you have also written. Okay, Ashwani has written B as 3. Lata has written B as 3. So please recheck your answers. So B is 4. Now I'll try to uh, do the calculation for the C part, which is x bar plus y. So I'll write in the next page. So it is nothing but x, what was that? X bar plus y. So x into x bar plus y. So it is nothing but x into x bar plus xy. So x into x bar is nothing but 0. We have just checked that basic axioms. It says that if you multiply the invert of any variable, it will be 0. 0 plus xy, so it will give xy. So this c is given by a 1. So I'll write here c as 1. I'll check with this d. Okay, d is xy plus xy bar, xy plus xy bar. So I can take x common from this. So it will be y plus y bar. So if we add the complement of any variable, it will always give 1. And if you multiply that with any variable, it will be the same as the variable. So it is x. So now d is 3. And only thing left is a, which is 1, 2. Okay, yeah. So this, we all know that this AND gate follows commutative property. So yeah, x plus y will always be equals to y plus x. So the correct answer to this question is A is 2, B is 4, C is 1, and then D is 3. So yeah, 2, 4, 1, 3. So yeah, side by side, I hope that you are also solving. Those who have written the answer as 2, 3, 1, 4, please confirm if they get the answer now. Ashwini and Latha. Yeah, Pavan, you are correct, and others, you are also correct. Okay. So yeah, these topics are quite easier that we are covering in this week. So please be interactive and try to solve as fast as you can. Okay. I'll wait for 2 minutes and we'll proceed. If you have any doubt, you can ask straight away. Okay. Till then, you can start doing the question if you have any idea. Okay. Okay. Is it better now? Is my voice quite low? Can anyone confirm? Or is it fine? Okay. Yeah, it is fine, right? Yeah. Thank you. So you can try to solve this question. This is a basic question of min term and max term. So I'll try to write something here. So I guess you all know that this summation defines min terms and this pi define max terms. Min terms is nothing but SOP, the sum of products of the variables. So if we have three variables, so we can write something into something plus something into something into something. This will be nothing but sum of product, and this is denoted by min terms. And there is one more term which is product of sums. So it will be something plus something into, and then it is like this. So this is denoted by max terms. So this question is a basic question of min terms, and we'll try to solve it by K-map. We can also do it without using K-map, but simplification will be easier if you use K-map. So we'll have a basic idea of K-map, and yeah. So do you have any idea of K-map? Hello, can anyone confirm if you have any idea of K-maps? Yeah. So those who have the ideas of K-map, please try to solve this question and type the simplified expression. Okay, we have got answer which is xy plus yz plus xz bar. Okay, so we'll see if it is correct or not. Okay, let me try to solve it now. So I make a k-map out of it. So it is a three variable k-map. So it will be something like this. Okay, my bad. Sorry for the bad handwriting. X bar x, and this will be y bar, z bar, y bar. This will be yz, and this will be yz bar. This will be 0, 1, 2, 3. This will be 4, 5, 6, and 7. So the terms which are 1 are 3, 4, 6, 7. So that 1, 1, 1, 1. Okay. So can anyone tell how many pairs can we make from this? Okay, we are getting different answers. Let me check. So Pawan wrote xy plus yz plus xz bar. So there are three pairs, Pawan is saying. Others is saying there is a single x bar yz. Okay, x bar yz is not even 1 in this. Others, please check your answer. Then Lata is also saying same as Pavan. Okay, we have got answer. Ashwani has said yz plus xyz bar. Xyz bar. Okay, we'll check Ashwani if you are correct or not. Fine, so let me try to solve it. So here you can see we can make a pair of this thing, right? And then we can pair this one with this one. So if I try to do something like this, there will be no redundance. If I make these two pairs, I'll be able to solve this question quite easily. So if I check this, so x plus, I hope you know this is nothing but x plus x bar into yz plus, if I try to solve these two, then it will be x and then y plus y bar into, okay, z bar, yeah. So this will be 1, we have studied 1 into yz plus again x into 1 into z bar. So if I try to solve 1 multiplied by any variable will be yz and then it will be xz bar. So this is the final answer to this is a simplified expression. So I guess many of you have written is as incorrect. So I hope you got it, Pavan and Latha. You are getting an extra variable named yz. So we don't need a repetition. Sorry, you are both are getting an extra variable as xy. So we don't want it. There is no need of writing. It is redundant. We have already covered these two ones. So we don't want again to cover these. Did you get the point? These are the redundant variables. So this is an important concept. And again, Adarsh and Ashwini, did you get the answer now? Please respond. Ashwini, did you get it? Lata, then Adarsh. Yeah, Sai, you have written the correct answer. Good. Please respond. I want this session to be as interactive as possible. So please respond. Okay, fine. We can also solve it without using KMap also. So as one of the Adarsh has written that he has not read KMap. So I hope you know that how to write 3, 4, 6, 7 as the variable. So 3 is nothing but 0, 1, 1. So we'll write as 3 as x bar y z. So it will be 0, 1, 1. I'm solving it without using KMap. So 4 is nothing but 1, 0, 0. So it is nothing but x, y bar, z bar. Then the third term will be 6, which is 1, 1, 0, x, y, z bar. And then 7 is nothing but 1, 1, 1. So I hope you know how I've written this. So this bar denotes wherever there is a 0. And this without bar terms denote that where there will be a 1. So it will be 0, 1, 1, which in decimal is 3. This will be 1, 0, 0, which in decimal will be 4. This will be 1, 1, 0, which will be 6, and this will be nothing but 1, 1, 1, which will be uh, 7. So if I try to take common, okay, x bar, y bar, z bar. So I'll take common y z. So I'll take this and the last term and the middle two term after that. So I'm taking from the last first in the last term. Wait, if I take yz as common, so it will be nothing but yz x plus x bar. And from the rest two terms, I'll take xz bar as common. It will be nothing but y plus y bar. So now we have read that if we add an invert of any variable to the same value, it will be 1. So it will be yz into 1 plus xz bar into 1. And if we multiply the 1 with any variable, so it will be the same as the variable yz plus xz bar, which is same as this answer. So this I have solved without using the K-map. So I guess others now you have got the idea of how we can solve without using the K-maps. But K-maps are always simpler than this method. Is it fine? Let me know if I can proceed further. Please respond everyone if I can proceed further. Okay, fine. So yeah, please try to simplify this expression to minimum number of literal required. So there is an expression that we are having in this question, which is nothing but what is it? X y plus y z plus x bar z. So try to simplify it if you can to lesser number of literals. Literals means variables. So if you can minimize the number of terms, you can try by your own. Then I'll try to solve it. I'll give you 1 2 minutes. So this is one of the postulate that we have. This is one of the theorem. So I'll try to cover it using this question. So I'll give you 2 3 minutes for that if you can solve and minimize this expression. Okay, someone has done it. Venkata, xy plus x bar z. Okay, we'll check if it is correct or not. You can take hint from the last question. It is nothing but similar to a last question only. So the third term you were taking earlier was redundant. I told you that we don't need to take this 6 and 7 term as another pair. So if I take that as another pair, so the third term will be nothing but xy. So this is a similar question. Okay, so there is a particular method to remove this literal from this. Okay, one has got x plus z. Okay, we'll check if it is correct. Okay, now let me try to solve it. So what we'll do is uh, I'll take these two term xy and xz bar is different and I'll try to play with this yz here. So here I can write xy plus x bar z plus and then with this yz I'll try to multiply the literal as x plus x bar. So we know if we multiply 1 by any literal it will again come as yz and 1 is nothing but x plus x bar. This will always give 1. So this is the trick that we should use in this question. Did you get this part? Can I do this? Will it remain the same if I add this x plus x bar? Please verify once if you get this part. Yeah, okay, Shani got this part. Everybody else? Okay. Yeah. So now I'll try to expand this x y plus x bar z plus x y z and then plus x bar y z. Okay, so now I'll take this and this term and then this and this term. So I can take xy from these two terms as common, which is nothing but 1 plus z, and then from these two terms common I can take x bar z, which will be nothing but 1 plus z. So we know that 1 plus any variable will always give us 1. I can write xy dot 1 plus x bar z dot 1, and 1 multiplied by any variable will always give the same variable. I can write this as xy plus x bar z, which is the redundant term. So we have removed this redundant term. Okay, let me try to, yeah, this term. We don't require this yz. So this is a important theorem that you can use in several questions, which is nothing but xy plus yz plus x z bar. It is nothing but xy plus x z bar. I hope you understood this concept. Yeah, so Sai, I hope now you get the correct answer because earlier you were getting something else. Yeah, so Venkata and Ashwini, you were correct. What about rest of the people? Are you also able to get the correct answer? Please respond. Okay. Okay, you can copy this, then we can proceed in 2 minutes. Okay. Okay. Yeah, so this is a basic question on number system. Maybe you can try it. I'll give you 2 minutes. Okay, I got some. Let me check your answers. 234 has written by others. Okay, we'll check. So we need to give the hexadecimal representation. I hope you know it. Hexadecimal is to the base 16. Others, please recheck your answer. I guess it is not correct. Anyone else? Okay, we have got one answer as 6E. One answer is 370. Okay, we are getting quite a number of answers. Fine, I'll try to solve it now. So there are two methods to solve this. One is basically we need to convert this to decimal first, and then we need to convert it to again to the base 16. And there is a shortcut, so I'll try to cover both of the methods. So 156 to the base 8 is nothing but 1 into 8 square plus 5 into 8 plus 6 into 8 to the power 0, which is 1. So this is 46 plus 64. So it is nothing but 110, I guess. So this is to the base 2. Please confirm if I'm correct. Oh, sorry. This is to the base 10. So to convert it to the base 16, we need to take divide it using now the 16. So if I divide it using 16, it will be nothing but 16 into, I guess, 6 plus 16 to the power 0 into 15. 1696. Okay, it is not 15, it is 14. Did you get this part? I have just divided it with 16 and just written the remainder here. Is it fine? Please, everyone respond. This is an important thing. Should I repeat? Uh, Please respond. Should I need to repeat? Do I need to repeat it? Okay, so yeah, so I just divided this decimal number by 16. So now I can write nothing but 6 and then 14. So we know in hexadecimal, so 0 to 9 are the same as 0 to 9. And for 10, 11, 12, 13, 14, 15. So hexadecimal goes till 15, which is 16 minus 1. So for 0 to 9, it is defined by the variable itself, and then 10 is denoted by A, 11 is denoted by B, then C, D, E, and F. So this will be nothing but 6 for the first part, and 14, as we have seen, it is denoted by E. So 156 to the base 8 will be nothing but 6E to the base 16. So yeah, Adarsh, you are correct. And then Pawan, you are also correct now. And Ashwani, you are also correct. Okay, Ashwani is not written. I'm sorry. So there is one more method to solve this problem, which is to convert it to binary and then convert it to hexa. So we'll try to do that. So for octal, what we do is for every variable that we have in this inside this bracket, we try to convert it into binary first. So we know that 1 is nothing but 0, 0, 1. Then 5 is nothing but 1, 0, 1. And then 6 is nothing but 1, 1, 0. So we have converted it to binary now. So this is the three variable. So if I try to take convert it to hexadecimal, I need to take four variables because 15 is nothing but 1111. So I should do it from the LSB. So one variable will be this, one variable will be this, and then rest will be zero. We can add extra zero as many as we want. So if I try to write it now zero, the first binary number is zero, and then if I take this is 0110, it is nothing but 6. And then if this hexadecimal number will be 1110. This is 14 in decimal. I guess you can do that. This is nothing but 8 plus 4 plus 2. This is 14. 14 is denoted by E in hexadecimal. So 060 is nothing but 6E only to the base 16. So this is the shortcut. So first we write whatever is given in octal as the binary of 3 digits, and then from the LHS we take 4 digits, and whatever is coming is the final answer. You can try to solve this question, maybe 237 to the base 8 by the shortcut. Please do it fast. Let's see what you are getting. Can anyone confirm what they are getting? Okay, I'll give you 2 minutes. Okay, I got one answer which is 9F. Anyone else? Okay, Ashwani is also getting 9F. Dhruti is also getting 9F. Fine. So let's check. So this 237 is nothing but I've written 7, 3, and 2, and then just took the variable. So this is 4 1, which is nothing but F, and this is 1 0 0, which is nothing but 9. So yeah, 9F is the correct answer to this 237. And for this, the correct answer is 6E to the base 16. Is there any doubt in this question? Okay, we can proceed then. Yeah. Consider the following circuit with three input variables. Okay, so we need to calculate the expression for the output D. Fine. So can you tell the expression like by giving by from the circuit what is D? It is basic combination of XOR gates. Can you tell me the expression of for D and maybe try to solve this question side by side? Okay. Anyone can tell? Okay, I'll try to write. So these, as you can see, it is nothing but here we are getting A, and here it is connected, and this is nothing but an XOR gate. I hope you know the symbol of an XOR gate. So here we are getting B XORed by C, and we are getting finally D is nothing but A XOR B XOR C. We can also write a truth table for that. A B C, and then we can write D. Here is 0 0. So for XOR gate, we know that it is a uh, odd parity generator. So wherever we are getting odd number of one, it will give one. So this is one, one, two, 16, one, zero, one, zero, zero, and then again one. So here we can see what we are getting. We are getting one, two, four, and seven as one. So yeah, you need to write, remember this. This is quite an important thing to remember. So if we have a three input XOR gate, so if we write it in terms of min terms, this is nothing but 1, 2, 4, 7. This is as in quite of the competitive exams such as GATE. So you need to remember this 1, 2, 4, 7. Wherever you can see this 1, 2, 4, 7, it is nothing but an XOR gate. So did you get this part? Okay, many of you are writing option B. We'll check. Yeah, option B is correct. Yes. Did you get this part? Please remember this 1, 2, 4, 7 is nothing but a combination of XOR gates. So if I try to solve this, 1 is nothing but 0, 0, 1. So it is represented by 0, 0, and then 1. Now 2 is nothing but 0, 1, 0. So 0 is represented by bar 0, 1, 0. Then 4 is represented by A, then 0, 0. And then 7 is nothing but 1, 1, 1. So I guess option B is similar to this. So this is 7. This is 0, 1, 0, which is 2. This is 0, 1, 0, 0, which is 4. And then this is 1. So yeah, option B is the correct answer. Did you get this question? Please respond if you have any doubts or if you got this. Okay. Everyone please respond. So Ashwini, Pavan, Venkata, you got the answer is correct. So the recording of this and yes, it is available. So you might have got a mail regarding that from NPTEL only. That the online recordings are available now. It is on YouTube also. You can check by the corresponding TA's name. It is present in YouTube. You can search my name and then type NPTEL. So they are available there. I'll type what you need to search on YouTube. Yeah, if you search this on YouTube, you will get the recording of previous week's lecture, which was given by me. And I'll upload the recording of today also on YouTube, and you will get it somehow from NPTEL also. I guess this question is clear. So, shall I proceed? Please respond. Yeah, everyone, please respond if I can proceed. Okay. Yeah, so this is one of the delay plus device question. Sorry, circuit question. So it says determine which of the following can be associated with the output waveform of the circuit Y. Initially at t equals to 0, x is 0 and y is 1. So let me try to make what they're trying to say. So if this is time t, so x is 0 for time t and okay, wait. Initially, let me try to change the color to green. Yeah, yeah. So x is initially 0, so I can write something like this, and y is initially 1. So here you can see this is the circuit. So if I make y as 1 initially and x at 0 initially, so uh, the question says then x is made 1 after duration of 1 propagation delay. So if I try to plot propagation delay also, like the time period, something like this. So these are the same peaks. Sorry for the background. So what is the output finally y now? So initially y is 1, and after 1 propagation delay x is made 1. Something like this. And initially y is 1 and x is 0. So you can see when y is 1 and x is 0, so the ultimately output y will be 0. So here the output y will be 0. Initially it will be 1, then it will get to 0. I hope you get this part. Did you get this part? Please respond. This is quite important. So initially x is 0 and y is 1. So I'm just making y as 1 initially, and after 1 propagation delay this x has been converted to 1. But now this y has been 0. So once this y gets 0 and this x gets 1. Did you get this part? So now again if I check this y is getting as an input to this gate as 0. So again 0 into 1 will be 0. right? So again, if I even take this x as 1, so this y will always be 0, as you can see, because since once this y will get 0, this AND gate, one of the input will always be 0. There will be no effect on this x variable, whatever it is, because 0 into anything will always be given as 0. So for few time period, this y will remain as 1 and then it will always remain as 0. Did you get this part? This is quite an important question. Okay. Sir, why y becomes 0? Okay. Yeah. So as you can see, at t equals to 0, x is 0 and y is 1. Let me try to change the color. Yeah. So it is saying that at t equals to 0, x is 0 and y is 1. So x is 0 and y is 1. So when I do the end of this 0 and 1, what I will get? Can anyone confirm? 0, yeah. So this is how this y is getting 0. Did you get this part? Sai and others, you did not get it earlier. So yeah, once you are getting 0, so once this y will get 0 now. So whatever they are saying that after the propagation delay, they have changed this 0 to 1. But the thing is now this y has become 0 and the input of x is 1 now. So this 0 and 1 will always give 0. So now again the y will be 0. And again if they try to give after one propagation delay x is 1, so there will be no effect of this x on this output since y will always remain 0 due to this. Did you get it now, Adarsh and Sai? Okay. So the final output will be y will remain 1 for some time, which is before the propagation delay of whatever the propagation delay of the x AND gate, and then it will always remain 0. So the correct answer to this question is A. Is it fine? Everyone, please respond. Okay. So, okay, there is a doubt, sir. At t equals 0, x equals 0, y 1, so it's not consistent since. Okay, wait. So others has a doubt at t equals to 0, x equals to 0, and y equals to 1. So yeah. So till t equals to 0 and y equals to 1. So there is no propagation delay we have counted till now. So initially the output y will be 0 because after one propagation delay this x is getting changed to 1. So initially we know that this output is for some time it was 1 but it will get to 0. And after one propagation delay, maybe this is the propagation delay of this AND gate, let's suppose. After this propagation delay, this x has been changed to 1, but the thing is now y has been 0 for the whole time. So this is 0, and even if we change this x to 1, now it will not get to 1. This will always remain 0. Is it clear now? Others, okay. There is one more doubt. Can you please explain the same question with NAND gate? Okay. Yeah, so it is fine. It is similar only. So if there is a NAND gate here, if I take the initial condition as same that x is 0 and y is 1. So y is 1 for some time and then 0 if I NAND it with 1. So it will remain 1, right? Uh, Pawan, please respond. Huh? You have asked this question. So 0, when I NAND it with 1, it will remain 1, right? Yes. So it will remain 1 till the propagation delay of the circuit. So now Should I keep this question as same, that x is made 1 after 1 duration? So yeah, if this will change to 1 and here we are getting 1. So now this will change to 0. I hope you get it. For that propagation delay, it will get changed to 0 because 1, when I NAND it with 1, it will be 0. So when output is 0, and again if I change this x to 1, 0 and 1 will again give 1, and this cycle continues, so on and on. So it, if I change it to AND gate, the answer will be D. Uh, Pawan, did you get it? Or everyone also? Please confirm if you everyone get the same. Yeah. Okay. Good. Uh, we can wait for 2 minutes. So I'll try to show the questions that I have covered till now. Yeah. So this was the basic question of Boolean algebra. Here we read about the basic axioms. Okay, wait. Yeah. So here we covered these basic, sorry, these axioms, and try to minimize this expression. Then a basic again Boolean expression minimization question. This was one of the K-map question, and I tried to solve it using both the methods since some of you are not aware of K-maps till now. Then this is an important theorem that there are redundant terms in K-maps that we need to remove, and we have proved it that how we can remove it using the basic Boolean minimization. Then again a decimal representation, hexadecimal representation. This is the basic. The yeah, you need to remember this, that this 1247 is nothing but XOR. Wherever it is written 1247, it is XOR. There are few more terms also which I'll try to cover maybe in the next week or so. There is a function called majority function. So if you can see this 3567 as summation. So this is nothing but majority gate, three input majority gate. And the expression of this is given by AB plus BC plus AC. You can, yeah, you can write this and remember this. This will help you in competitive exams also. So 3567 is nothing but the majority gate, and the output is given by AB plus BC plus AC. And how is it working? Okay, let me tell you that also. Yeah, I'll repeat it. So majority gate, what it does is, suppose this is Y. So wherever there are more number of ones than zeros, it will assign that value to one. So there is no one here, right? So it is zero. It has one and two zeros, so it is again zero. It has one and two zeros, so it is again zero. Now this value has two ones and one zero, so this is one. Again this is zero, this is one, one, one. So this is nothing but 3, 5, 6, 7. Did you get this part? So yeah, so this 3, 5, 6, 7 is nothing but majority function. So if I implement it using K-map and solve it, uh, so 3, 1, 2, 3, 4, 5, 6, 7. Yeah, sorry, this is 4, 5. This is not there. So yeah, this is the K-map, and when you minimize it, you will get something like AB plus. How do you represent 1, 2? Yeah, 1237 is nothing but XOR gate. So wherever it is written 1247, it is nothing but A XOR B XOR C. And the simplified expression is here. This option B is nothing but XOR gate. And this is majority function, so you represent majority function by AB plus BC plus AC. Okay, wait. Yeah. So these two terms you need to remember. 1247 is XOR, and this 3567 is majority gate. Is there any doubt in this? Okay. So now the next question we covered. Yeah, this is the last question that we covered. Is there any doubt in this question? Do I need to repeat this? I can repeat it if you want to once more. Please respond if you want it to get repeated once more. Okay. I'll try to repeat it again. So yeah, in this question, what is given? There is a AND gate. Let me try to erase it. Okay. So yeah, it is given in this question like that initially x is 0 at t equals to 0 and y is 1. So here I have plotted that x is 0 at t equals to 0 and y is 1. So I'm assuming that after one propagation delay, it is given that x is made 1. So what will be the output waveform, which is nothing but y. So initially y is 1, and then after one propagation delay, this x has been made 1. So as you know that this y is 1, so once I input this as 1, so initially the output of the circuit will be 0 only. So inside that propagation delay, this will get converted to 0. So this propagation delay is, let's suppose, somewhere here. So now this output has become 0, and now they have changed this x as 1. So this 0 has now come here. So this 1 and 0 will again give 0. Did you get this part? Who said to repeat the others? Yeah, others, did you get this part? Please respond. Hello. Okay, I cannot link. So this propagation delay, I'm telling that this propagation delay is maybe here. This propagation delay means this x is getting 1 after this thing. So before this x was completely 0, and after this x has become 1. But the thing is, before that only this y has become 0. Did you get it now? I'm saying that after this propagation delay, this x has become 1, but the y has changed to 0 before that only, because y has initially been 0. Y is 1 and x is initially been 0, given in the question. So now once this y will get 0, there is no chance of getting uh, whatever the x is, there is no chance of getting this y as high. This y will never get 1 because of the nature of the question. So it will always remain 0 after that. I hope you get it now. Did you get it? Want to know the circuit, sir? Okay. Did you get it, others? Okay. Anyone else? Do I need to repeat it again? I can if you want to. Or shall I proceed now? Please respond if I should proceed. Okay, fine. So you can also try it side by side. So it is a question of SOP and POS. So there is a already a POS term given, and we need to convert it to its equivalent SOP form. So I told you POS nothing but product of sum. So here you can see, uh, yeah, it is nothing but first they have summed the term and then they have multiplied it. So it is nothing but POS. And these options you can see they have first product the term and then they have summed it. So this is nothing but SOP. So there are few things that you need to check for SOP and POS. So SOP is nothing but summation, which is denoted by min terms. And in min terms, bar denotes 0 and normal term denotes 1. POS, it is nothing but multiplication, which is pi, and these are also called max terms. In this, bar denotes 1 and the normal term denotes 0. Okay, someone has turned on the microphone, I guess. Please turn off, whosoever it is. BR, please turn off your microphone. Yeah, I muted it. So, yeah, so what I was telling is POS is nothing but in that bar denotes 1 and the normal term denotes 0. So we can directly convert this SOP into POS. So we can check which integers are this representing. So it is given as A plus B plus C in multiplication with A plus B bar plus C bar. So I said that normal term denotes 0. So this is nothing but 0, 0, 0, and this is 0, 1, 1. So this is nothing but 3, and this is nothing but, oh sorry, this is nothing but 0, and this is nothing but 3. Did you get this part? Please respond. Okay. So apart from these term, rest of the term will be nothing but max terms. So from 1 to 7, there will be 1, 2, 3 is not there, 4, 5, 6, 7. So if I try to convert it into POS, so it will look something like this because 0 and 3 are the max term that they have used. So the complement of those terms will be the min terms. Did you get this part? Apart from this 0 3, everything else will come under the min term. So now let me try to write this. One is nothing but now in max term, sorry, in min term, as we have seen, bar is denoted by 0 and a normal variable is denoted by 1. So 1 is 0 0 1. So it is A bar, B bar, C. Then 2 is 0 1 0, A bar, B, C bar. 4 is A, B bar, C bar. 5 is A, B bar, C. 6 is A, B, C bar. And 7 is A, B, C. So this is option, I don't know, A, B bar, C bar. So okay, these three is fine. A bar, B, C bar. Okay, this is fine. And this is all fine. Can you tell which is the correct option? We have done it. A, B, C bar. Then A, C. Yeah, option C is the correct answer. Is there any doubt in this question? This was one of the another question where I've converted one of the concept of SOP and POS. So you need to remember these things. Yeah, majorly these. That SOP is min terms and bar denotes 0 and non-bar terms denote 1 and POS is max term and here bar denotes 1 and non-bar terms denote 0. So yeah, once you have converted this, that 0 and 3 are the max terms, so rest of the terms will be min terms. And I've just expanded it and I've got the correct answer at C. Is there any doubt in this question? Please respond. Everyone please respond so that we can proceed. Okay, fine. Okay, so check all of these if okay, I have told you I guess some of these. So it will help you the whatever the question that we have covered, it will help you in covering this. So let me know what is the correct answer to this question. Okay. Others has written C. Anyone else? Please respond. Okay. Ramadevi is also saying C. Yeah, Ashwini is also saying C. So I've covered two concepts in the earlier question. One of them was wherever you see this summation 1, 2, 4, 7. So it is nothing but XOR gate. Then one more combination that I covered was wherever you see 3, 5, 6, 7. It is nothing but majority function which is given by AB plus BC plus CA. So this first option is nothing but the right part says this only, but it is not 3, 5, 6, 7. Now the second part says 3, 5, 6, 7, but it is not given by this. It is AB plus. This is also not wrong. Also not correct. Now this D option is AB plus BC plus CA, but this is not correct now. So if we check this C option, it is 1, 2, 4, 7, which is nothing but the XOR combination. You can even. I hope you get the question because I have already covered both of these concepts earlier. Do I need to expand it and solve it? Okay, yeah. So this is one of the basic questions that. Hmm. So you can see that previous question is helping you in solving these complex question. It will not be easier if I have not solved those questions earlier. So I hope you are getting it. The importance of remembering these terms, majority function and XOR gates. We can proceed in 2 minutes. So if you have any doubt in this question and even in the previous question, you can ask. And if you don't have any doubts, you can write no. Okay. Okay, we can proceed in 1 minute then. Fine. This is one of the theoretical question. So can anyone tell the correct answer to this? I'll tell you what is associative means. Associative means nothing but x plus y should be equals to y plus x, or x into y should be equals to y dot x. So for the first question, option it says and or operations are not associative. So we can see and or they are both associated. So this is not correct. Then the second option says NAND and NOR are associated. If I do a NAND, it should be equals to something like this. Something like this. Yeah. Still y. Then y plus y. They should be equals to. Since we are using De Morgan's here, so yeah. So this is what we call as pseudo associativeness. They are not associative directly, so you cannot write directly as that NAND and NOR gates are associative. Since if I try to change this as three variables, let's suppose maybe y plus z, so it will not give the correct term. So NAND is nothing but x bar dot y bar. If I change to y plus z bar, so it is not similar to x plus z bar into y bar. So yeah, that is why NAND and NOR are pseudo associative. They are not completely associative. But this is also not correct. And NOR are completely associative, as we know. Even if I do this plus z and plus z here, or into z and into z here, this will always be associative. So this is also not true. The correct answer to this question is option D. Is it fine? This is a theoretical question, so I hope this is fine. Please respond if it is fine. Okay. So shall I proceed? Okay. This is a question maybe you all can try. This is a six variable question which says that f is nothing but ace plus b d bar e bar plus this long term. Let me try to write it here. A d e c plus e bar f, and then nothing but b c plus d f. So try to simplify it and let me know. Both x, y, z and yes, they are same for AND gate. So please try to solve this. I'll give you a hint. You should try to solve this long term. Please respond if you're getting any answer. Okay, here there is a typo in this question. This is D F bar, not F. Um, no, no, no. I'll repeat. This is D bar F, not D F bar. So this is D bar F. Now try to solve the question. This was not D F. This was D bar F. Please correct the question and then try to solve it and let me know what is the answer that you are getting. Okay. Okay. Anyone else? Okay. Two people are getting A. Anyone else? Okay, let me try to solve it this long term only. So here you can see there is an E bar here and there is an E here. So E bar will always will get 0 and 0 multiplied by anything will be 0. So we will be left with only this term in multiplication with this term. So similarly this CC bar will become 0 and we will get something as ADE into 0. And then this DD bar will become 0 and we'll get something like AC DD bar F. So this will be 0 only. 0 into anything will be 0. 0 plus 0 will be 0. So this whole term will get neglected and there is no option to further minimize these two terms as they have nothing in common. The correct answer to this question is option A only. Is there any doubt in this question? Okay. I'll proceed in a minute only then. I'll not wait much. Till then you can try this question. This is again one of the concepts that we'll try to cover. You can try this for both odd and even. Okay, is there any answer that you have got for this question? Okay, someone has got A. Option A or option A is 0. Please be clear, Santosh. Is it option A or option C? Okay. Anyone else? So Santosh is getting option C. We'll check if he's correct or not. But anyone else who's got any answer? Please respond. Or should I do it by myself? Okay, I guess I need to do it by myself. No one else is responding. So it is given that Fn is nothing but Fn minus 1 complement plus A. And it is given in the question that F1 is nothing but A. So if I try to calculate F2 from here, it will be nothing but F1 complement plus A. F1 complement is nothing but A bar. A bar plus A will always give 1. Is it fine till here? Do you have any doubt? I have just calculated F2 from here. Is there any doubt? Okay. Now I'll try to calculate F3 similarly. F3 will be nothing but F2 complement plus A. F2 was nothing but 1. So 1 complement will be 0. And 0 plus A will be A. Here you can see we are getting a pattern here. F1 was A, F3 was A. So if I try to calculate F4 now similarly, it will be nothing but F3 complement plus A. which will be again a bar plus a, and this will be 1. So here you can see, if I try to make it with different color, yeah. So here you can see for even you're getting F2, F4, you're getting as 1, and for odd you're getting F1, F3. Let me calculate F5 also, that will confirm further. It is nothing but F4 complement plus A. This will be 0 plus A, and this will again be A. So you can say when n is odd, we are getting Fn as A, and when n is even, we are getting Fn as 1. So here we have asked as odd, so the correct answer is C. Okay, even 1, odd 1. Oh yeah, odd A. So this is fine, I guess. So let me try to give you one more question similar to this. So if I take Fn as Fn minus 1 complement plus A complement. A complement, this is nothing but A dash. So can you tell me for n equals to odd and n equals to even, what will be the answer? I'll give you 2 minutes. And again, F1 is A only. I'll try to solve it side by side. Even 1 odd A bar. Okay, let's check. F2 is again F1 bar, which will be nothing but A bar plus A bar, that is A bar. Okay, 2 is. Oh, F1 is 1. Sorry. This will be 1 only. Now F3 will be 1's complement, which is 0 plus A bar. Then F4 will be A plus A bar, which will be again 1, and F5 will be 0 plus A bar. So yeah, this cycle repeats now. A bar, A bar. So for n equals to even, it will be 1, and for n equals to odd, it will be A bar. Yeah, so others you are correct, Ashwini you are also correct. And yeah, you can fine. I hope you get the concept from these type of questions. Is there any doubt? Please respond. Please respond so that we can proceed further. Shall we proceed? Please respond. Okay. Okay, so this is a K-map question now. You should try it by yourself, and then I'll also try to do it. So you need to just simplify the Boolean expression or the function given. And I hope you know this D denotes don't care. And this summation M denotes the midterms. Yeah, and summation D is again don't care. So please try to solve this question and let me know what is the answer that you are getting. I'll give you 2 minutes. Then I'll solve it. You can use K-map for this question. Okay, someone is getting B. I will check. Let's wait for one or two more answers. Anyone else who's getting any answer? Yeah, someone has raised a hand. Is there any doubt or you are getting any answer? You can type your answer. Okay, B plus C. Okay, fine. So I got most of the answer is B only. So let's check if you all are correct or not. So make a key map. Okay. So nothing but 0, 1, 2, 3, 4, 5, 6, 7. I hope you know how to fill this K map. 8, 9, 10, 11, 12, 13, 14, 15. The question it is given is 2, 3, 4, 5. Which is this. And don't get out 10, 11, 12. 10, 11, 12, 13, 14, 15. Okay, this whole. Let me try to write here also. This is nothing but A bar, B bar, A bar, B, A, B, A, B bar. This is nothing but C bar, D bar, C bar, D, and then C, D, and then C, D bar. So how many pairs or chords are forming in this equation, in this K map? Can you please confirm the number? How many pairs or chords I can form? So Ashwani is written two. Two pairs or two chords? Yeah, so two chords are forming in this. So one of the chord will be this, and one of the chords will be this. Let me try to change the color. So I'll shade it. One is this, and one is uh, this. So if I try to cover it, it will be nothing but A plus A bar into B plus. Oh, sorry, not plus. Someone has opened the microphone. Please mute it. So yeah, multiplication with C bar plus into D plus D bar. The first term will be nothing but BC bar, and the second term will be, if you can check, it is directly B bar and C. So BC bar plus B bar C. So this is nothing but XOR. I hope you get this. How to write this using KMap, right? You all know, right? How to write these terms using KMap. Okay, good. So this is nothing but BC bar plus B bar C, which is nothing but the expression for XOR gate. So the correct answer is yes. It is B only. I hope you get the question. This was quite easy. Please let me know if there is any doubt. I can cover it again. Okay, no doubts. Shall I proceed then? Okay, let's see. Yeah, so this is a good question. BR, you are again turning off your mic. I'll remove you if you do it again. I'm doing it for the last time now. Yeah, please try to solve this question. And let me know if anyone is getting any answer. It's complement. Okay, X complement. So there are two options. Should I proceed or anyone is doing? Shall I do the solution? Okay, I'll do it. So yeah, it is given that there are n number of XOR gates. So you can see the input here is X and here there is 1. So there are few properties of XOR that you need to know for this. So if I do a XOR of X with 1, it will always act as an inverter. If I do a 0 of any XOR, it will act as a buffer. Whatever the variable is, it will give the same variable. If I do XOR of same variables, it will always give 0. And if I do XOR of inverted variables, it will always give 1. These are the properties that you need to remember to solve this question. I hope you know these properties. Oh, buffer. Buffer is nothing but whatever input you are giving, you are getting the same output after a certain delay. So buffer circuits are nothing but whatever input you put, you get the same output after getting a certain delay. So I'm saying that if 0 is applied to an XOR gate, so whatever input you have applied, you will get the same output. Is it clear? Is it clear, others? Okay, so I'll do the question now. So it is given that 1 and X are getting XORed. So I've just written that whenever 1 is given, so it will act as an inverter. So here we'll get X bar, and here there always will be X. So X and X bar, once they will get XORed, they will always get 1. So here you can see a certain patterns getting repeated. 1x, then x bar x, then 1x, then x bar x. So you can see for, let me try to change the color. Yeah. So for odd number of gates, we are getting a certain output as x bar, and for every even number of gates, we are getting a certain output of 1. So if we are having two XOR gates like this, we will always get output 1. You can check. If I have one more gate, let 1x, so this will be the third gate. So this will be x bar. So question is, why is if x is consisting of odd number of gates? So odd number of gates, it is giving x bar, and for even number of gates, it is giving y bar. It is giving 1. So the correct answer to this question is option B. Is there any doubt in this question? This is quite an important question for competitive exams also. So if you have any doubts, you can ask. Is there any doubt? Okay, yeah, I'll explain the condition. So I'll explain with the questions only. Like 1 XOR X. So we know that XOR is nothing but if I take A XOR B. Okay, you have again muted. I need to remove. Yeah. So we know that it is A B bar plus A bar B. Is it fine? Okay, I think C. Okay, okay, yeah, yeah. The answer is C. Yeah. I did not read it correctly. So for the first input, it is asking for 20, and for the second, it is asking for odd number. Yeah. So yeah, I repeat, the correct answer is C, not B. So I'll try to explain the conditions again. So if I do this with this, 1 into x bar plus 1 bar into x. So this will be 1 into x bar plus 0 into x. This will be nothing but 0, and this will be x bar. So 1 into 1 XOR with x will always give you x bar. Did you get the first? Uh, who was asking? Yeah, Ashwini was asking. Yeah. So now the second will be similar to 0 into x bar plus 1 into x. It will give x. So this will be the second. Then third will be x into x bar plus x bar into x. This will be 0. And then fourth will be x plus x bar. This will be nothing but x plus x bar. And this will be 1. So are these conditions clear now, Ashwini? X XOR x bar, how it's x bar? X XOR x bar is 0, not x bar. I'll repeat it. X XOR x bar. It is X XOR x bar you are asking? Yeah. So it will be 1 now. X bar plus x bar x bar. So we know x into x is x, and then x bar into x will be again x bar. And we know x plus x bar will always be 1. So this one you are asking, Adarsh. So Adarsh, is it clear? X XOR x bar is not x bar. X XOR x bar is 1. Yeah. So the correct answer to this question is option C. I'll make it a bit different. This is the correct answer. Is it fine now? Shall I proceed, or do I need to explain anything else? Shall I proceed? Okay. So yeah, again one more question. Yeah. So already a K map is given. So can you tell me? Uh, so there is a K map and there are variables A, B, C, D. So find the minimum number of gates required if this logic is implemented using two input NOR gate. So NOR gate is nothing but this. NOR gate is x, y, and it is given by x bar into y bar, or x plus y whole bar. So how many NOR gates are required to minimize this? First of all, we need to calculate an expression for this. So what will be the number of quads that we can make using this? Can anyone tell? Number of quads or octet or pairs, whatever. Okay, Yuvraj. Yuvrani is saying 2 and others is saying 1. Anyone else? Acha, now you are also saying 1. Okay, everyone is saying 1 now. So yeah, the correct answer is 1 only. So only this quad will be there. We don't need to cover any separate don't care quad. So this will not be a quad. I hope you are getting that we don't need to cover these don't care, as they are unnecessary. So the correct chord will be this one only, and by expression I can write it as C. Okay, this is D plus D bar into C plus again this is B plus B bar, and the last term will be A bar. So the correct answer is A bar C. Is it fine? So A bar C we can easily get from a NOR get. What we need is A bar C na, so we can apply A and C bar here, and we will get A bar C. Is it fine? Since I have used C bar because it in the question it says that respective complements are also available as an input. You can see here A bar, B bar, C bar, D bar are also available. So once I do a NOR of A plus C bar whole bar, it will be nothing but A bar into C. Is it fine? Everyone please consider. So the correct answer is only one NOR gate is required to realize this expression. Please respond so that I can proceed. We are running out of time. Okay, I'll proceed then. Yeah. To simplify the following using Boolean theorems. So yeah, let's do it uh, a bit faster. You also try to do it from your side. So it says a hint subsequently verify using K-map minimization. So I will first minimize this term. So it is nothing but A plus B, and then it will be A plus BC. And A plus B, A plus, I hope you know the distributive property. So A plus BC is nothing but A plus B into A plus C. And when I multiply the same with this, so only this will remain. A plus BC plus the rest of the terms are A bar, B bar plus A bar, C bar. So I'll repeat again, this term I've changed to A plus BC using De Morgan's theorem. A bar bar plus B bar bar into C bar bar. So this is nothing but A plus BC. And using distributive property, it is nothing but A plus B into A plus C. And there was another A plus B here in the question. So x into x is always x. So that is why I just wrote it to A plus B into A plus C, and again reduce it to A plus BC. So these two A plus BC are these two terms, and the rest of the terms in the question are these. Is it clear? So if I use K-map, okay, so there are three terms only. Sorry, I made it very bigger. So this will be 0, 1, 3, 4, 5, 6, 7. This will be A bar, A, B bar, C bar, B bar, C, B, C, B, C bar. So the terms are A. So A row will always be 1. Then the next term is BC. So this row will be 1. I hope you are getting it, right? Since there is one term named A, so this row will needs to be 1 to get that term. Then there is a term named BC, so this column needs to be 1 to get BC. Then there is one more term A bar, B bar. A bar, B bar will be 1. So this is B bar. This is also B bar. A bar, B bar will be 1 when both of these will get 1. And this last term is A bar, C bar. So A bar, C bar, and this. So yeah, this whole K map is 1 now. So there is one octet that is forming. I hope you know this will give 1 as the answer. Is there any problem in this question, or is there anything that you did not get? I've covered it a bit faster because we are running out of time. Do you have any problem? You can ask. We can cover the rest of the question in the next session also. So you can ask if you did not get any part. Is there any doubt? Please confirm. Okay. All of you, please confirm if you have any doubts. How you filled A in K-map? Okay, yeah, I'll repeat. Different. Yeah. So if I make a K-map here, we can, yeah, we can also directly simplify it. B bar C bar, then B bar C, B C, and then B C bar. So for A, for complete A, we know that we need to have this row, complete row as one. Then only this whole term will get one, and we'll get a something as sum as A. So this is how I filled A in this K map. As you can see, if I try to minimize it, it will be nothing but B plus B bar and C plus C bar. So if this whole row will be one, then we'll get the output as A. Is it? This is what I have done. So is it clear now that how this A has been filled in this K map, or is okay? So now rest of the term are BC. So as you can see, BC here there is BC. So this whole column needs to be BC. Needs to be one. Then only we can get BC as one of the other term. And then again A bar B bar. So A bar B bar are this term and this term. So these both needs to be one. And for A bar C bar, this A bar C bar and the last term needs to be one. So that is how we are getting output as one. So the correct answer to this question is option A. Is it fine? Okay, let me see. Fine, let me cover this question also. So here it is given that x is 1. So what will be the value of y or z, whatever they have given. So I'll try to solve this by bracket first. So here it is given as x bar. So this will be 0 plus z bar and 1 plus y. 1 plus anything will be 1. So this bracket will get reduced to z bar. I hope this is clear. I'm doing it a bit faster. And this says y x plus, okay, so x is 1 and 1 plus anything, whatever it is written, we don't need to check it. 1 plus anything will be 1 only. So if we solve it, then this will be something 1 into z bar is 1. So it will always be 1 when this z bar will be 0 or z will be 1. I hope you get this. Yeah, so the z will be 1. This is a basic question. Is there any problem? Do I need to explain it again? Anyone having any doubts? I've done it a bit faster, but I can explain if you still have any doubts. Anyone? Okay, I'm proceeding then. So maybe already the time is over. So for the next session, maybe you all can do one thing. You can note these questions. I'll start the next session with basic three questions of NAND or universalization. So you can note these questions that how many minimum number of NAND gates you require to uh, make this logic. Minimum number of two input NAND gates, not AB plus CD. Minimum number of two input NAND gates. So it, it came Z bar. Okay, so 1 into Z bar is coming as 1 according to the question. Z bar needs to be 1 to realize that. So that is why Z bar needs to be 1. Yeah, so Z is 0. Sorry. The correct answer to this question is Z equals to 0. Yeah. So 1 into Z bar needs to be 1. So for that, Z needs to be 0. Then only it will come as 1. So I am repeating the correct answer to this question is C. Z equals to 0. Is it fine? Please everyone respond as we are running out of time. Is it fine? Okay, I hope it is fine. So you can note out these questions. So you need to tell me the minimum number of NAND gates you require to realize this expression, which are two input NAND gates. Then the next question is minimum number of two input NOR gates required to realize A plus B into C plus D. I did cover one topic which is known as AND or implementation in the last week also. That will help you in solving these questions. And then there is one more question, minimum number of NAND gates required to express two input XOR gate. So please come with the answer of these three questions in the next week session at the same time that we'll have on Tuesday. Sorry, on Monday. So yeah, these are the questions. And again, repeat, using NAND, you need to realize AB plus CD, two input. Using NOR, you need to realize A plus B into C plus D. And using NAND, you again need to realize two input XOR gates. So come up with a number before the session starts. I'll cover these questions and then I'll proceed to further questions. Is it fine? Do we have doubts in this session? Yeah, on Tuesday you will have some other questions from some other TA of the course. I'll cover the same questions in Monday. These questions will not be covered tomorrow. So I guess I need to wrap up the session. So we'll meet in the next week now at the same time, 6 to 8. So I hope this session was useful. Can you please comment if is it fine? Should I wrap up the session now? Yeah, fine then. Thank you for joining the session. Let's meet next week at the same time. Thank you.